show that 0,4 recurring is rational. This means that we have to show that it can be written in the form a over b. Okay, it can be written as a fraction. So what we do, I want you to follow these steps. The first step, let your recurring decimal be x. So we say x is equal to 0,444, because 4 is recurring, so it goes on like that. And then that's equation 1. And then the next step, you multiply both sides of the equation by the powers of 10. That means you can multiply by 10, by 100, by 100, by 1000, by 10,000, and so forth, to get equations that have the same decimals after the comma. So the main aim here is that we get equations that have the same decimal after the comma. And then if the decimals are the same, it means they will cancel each other out when we subtract them. Let's say we have 3,125, 125, 125. And then we subtract 1,125, 125, 125. You see that? So the decimals are going to cancel each other out because they're going to cancel each other out because they'll give us zeros here. And then you'll get 2. So it means our answer is just going to be 2. You see that? So we have to make sure that our decimals after the comma are the same. Right. Let's just create 3 equations. 3 equations. There's no need to create a lot of equations if you have the same decimals after the comma, but I'm going to create 3 equations because I'm explaining. So here, let's multiply by 10 both sides of the equation. So it's 10x. Multiplying by 10, the comma just shift by 1 unit to the right. So it becomes 4, 4, 4, 4, 4. That's equation 2. Then let's create equation 3. Multiply by 100, both sides. Multiply by 100, the comma will move. How many times? 2 times to the right. So it's 1, 2. So it's going to be 44, 4, 4, 4, 4, like that. That's equation 3. So if you check all our equations, we can use them because they have the same decimals after the comma. So let's start with 1 and 2. Subtract equation 1 from equation 2. So we're going to say 10x minus x, we're separating this and that, is equal to 4,444 minus 0,444. So it's 4,444 minus 0,444, like that. Okay, and then the decimals are going to cancel each other out because if you subtract them, they're going to give us 0. So it's just the same as 4 minus 0 there. So 10x minus 1x is 9x. And then 4,4444 recurring minus 0,444 recurring will give us 4. Then now what we get, remember this is our x, we want to get x. Then we divide by 9 on both sides of the equation. 9x divided by 9 is equal to 4 divided by 9. So x is equal to 4 over 9. So we've written this recurring decimal. So it means therefore 0,4 recurring is equal to 4 over 9. You can use your calculator to confirm that. Okay. We could have used equation 2 and 3 because they have the same decimals after the comma. So we could have used equation 2 and 3. Let's subtract 2 from 3. Okay, what we get? 100x minus 10x is equal to 44,444 minus 4,4444 recurring. Then 100x minus 10x is 90x. And then 44 minus 4, because the decimals are going to cancel each other out when you subtract. So we're getting 40. And then we say divide by 90 on both sides of the equation. We get that x is equal to 4 over 9. 40 over 90 reduces to 4 over 9. And we could have used also equation 3 and equation 1. Let's just do that. We say we subtract equation 1 from equation 3. Subtract equation 1 from equation 3. So it's going to be 100x minus 1x is equal to 44,444 minus 0,444. Okay, it goes on like that. And then 100x minus 1x is 99x. Then 44,444 recurring minus 0,444 recurring is 44. And then we can divide both sides by 99. And then 11 is the highest common factor there. We can divide 44 by 11, get 4. Divide 99 by 11, get 9. You see that we're getting the same thing. Let's go to the next question. Let's have our recurring decimal as x. So x is equal to 0,125, 125, 125. That's what it means. It goes on like that. That's equation 1. And then let's multiply by 10 and see what we're getting. So we multiply by 10. 10x is equal to, the comma moves here, it becomes 1,25. The comma moves one step to the right, so it becomes 1,25, 125, 125. If you check now, the decimals after the comma are not the same. Let's multiply by 100. 100, the comma will move 1, 2. So it's going to be 100x is equal to 12,5, 125, 125. It goes on like that. That's equation 3. Again, the decimals after the comma are not the same. Okay, let's multiply by 1000. 1000, the comma will move 1, 2, 3. So it's going to be 1000 here. X is equal to 125, 125, 125, 125 like that. So that's equation 4. And then if you check this, equation 1 and equation 4, the decimals after the comma are the same. So we can use equation 1 and equation 4. This is subtract equation 1 from equation 4. Right, so it's going to be 1000x minus x is equal to 125, 125, 125 goes on like that, minus 0,125, 125 going on like that. 1000x minus 1x is 999x. It's equal to 125 minus 0, because these decimals will cancel each other out when we subtract, so we just remain with 125. Then divide by 999 on both sides of the equation. 999, 999. So it means x is equal to 125 over 999. So 0,125 is equal to 125 over 999. Then let's do the last one. Let's make our recurring decimal be x. So x is equal to 4,215, 1515 recurring. That's equation 1. And then let's multiply by 10. The comma will move one step to the right, so it becomes 10x here is equal to 42,151515. The decimals after the comma are not the same. This one is 2151515. Here it's just 151515. So we can't use equation 1 and 2. Let's multiply by 100. So the comma will move how many times to the right? 1, 2. So it's going to be 421,515. So 100x is equal to 421,51515 going on like that. We don't have any equation here with the same decimals after the comma. This one is 2151515. This one is 151515. This one is 51515. So they are different. Let's multiply by 1000 now. 1000x. The comma will move 3 times to the right. 1, 2, 3. So it's going to be here. It's going to be 4,215,151515. So that's equation 4. If you check equation 2 and equation 4, they have the same decimals after the comma. So we can use them. So let's say subtract equation 2 from equation 4. Say 1000x minus equation 2, 10x is equal to 4,215,151515 minus 42,151515. 4,215 minus 42 is 4,173, and then here 1000x minus 10x is 990x. So divide both sides by 990, becomes x is equal to 4,173 divided by 990, which is equal to 1391 over 330. So therefore 4,215 recurring is equal to 1391 over 330.